So I'd like you to join me in welcoming to the stage the hugely deserving Arthur C. Clarke Lifetime Achievement Award winner, Lord Martin Rees.
Shall we present the award? Would you read it? Would you?
Well, it's a great pleasure and privilege to be here alongside two celebrities whose luminosity I can't match on an occasion celebrating the great Arthur C. Clarke. I was inspired especially by his prophetic book, Profiles of the Future. Can I get my slides? Yes. Because I've got the title Astronomer Royal, I'm sometimes asked, do you do the Queen's horoscopes? I respond, I'm the man she'd asked, but she's never asked me. But in fact, of course, I'm not an astrologer. I've got no crystal ball. Like most scientists, in fact, I'm a rotten forecaster, though economists are even worse. We lack the insights of imaginative writers, like Sir Arthur, who can explore possible futures, as well as those who illuminate the past. Sir Arthur was excited by scientific discovery, but he was mindful that the world's future depends on its application to technology and engineering. He developed a New Yorker cartoon which shows two beavers looking up at a hydroelectric dam. One says to the other, I didn't actually build it, but it's based on my idea. And armchair theorists like me feel very modest compared to those who build things that work and meet public demand. And I tell my cosmologist colleagues that the Swedish engineer who invented the zip fastener made a bigger intellectual leap than most of us ever will. Arthur would have been disappointed, actually, at the slow advances in space technology. We depend on it every day for sat-nav, environmental monitoring, communication, and so forth. And robotic probes have beamed back pictures of the planets and of Saturn's moon Titan and of... Sorry, it's running away by itself now. Yes. Okay. Well, anyway, that's Pluto. Which is 20,000 times further away than the moon. But the Apollo program, there we are, 50 years ago, remains a high point of manned spaceflight. And that's partly because the funding was thereafter not boosted by superpower rivalry, and also because the practical case for manned missions is weakening as robots get better. Nonetheless, there's still clearly the urge to explore. And by 2100, courageous thrill seekers may have established... Sorry, can we stop these going off on automatically? Thank you. Yeah. By 2100, courageous thrill seekers may have established bases on Mars. I think these ventures will be high-risk and cut-price ventures spearheaded by private companies, which are able to accept higher risks than NASA can impose on publicly funded civilians. Elon Musk says he wants to die on Mars, but not on impact. But don't expect mass emigration to Mars. Can we go back again? Nowhere in our solar system offers an environment even as clement as the Antarctic or the top of Everest. Here I disagree with Musk and my late colleague Stephen Hawking. I think it's a dangerous delusion to think that space offers an escape from the Earth's problems. Dealing with climate change here on Earth is a doddle compared to terraforming Mars. There's no planet B for ordinary risk-averse people. Nonetheless, we should cheer on those brave space adventurers because they'll be pivotal in determining what happens in the 22nd century and far beyond. This is why. By 2100, we'll surely have developed super powerful genetic and cyborg techniques. These techniques will, one hopes, be restrained here on Earth on prudential and ethical grounds. But the settlers on Mars will be beyond the clutches of the regulators, and they'll be ill-adapted to their new habitat, so they'll have a compelling incentive to redesign themselves. So it's these bold spacefaring adventurers, not those of us comfortably adapted to life on Earth, who will spearhead a post-human era. This future evolution, a kind of secular intelligent design, would take only centuries to change a species, in contrast to the thousands of centuries needed for Darwinian evolution. And this is a game changer. When we admire the literature and artifacts that have survived from antiquity, we feel an affinity across a time gulf of thousands of years with those ancient artists and their civilizations. Human nature was the same then as now. But we can have zero confidence that the dominant intelligences a few centuries hence will have any emotional resonance with us, even though they may have an algorithmic understanding of how we behaved. And some, like this man, Kurzweil, believe they can live forever, that aging is a disease that can one day be cured. Indeed, this belief leads some to patronize a company in Arizona that will freeze and store your body so that, they claim, when immortality is on offer, you can be resurrected or your brain downloaded. I was surprised to find that 3 academics in England had gone in for this cryonics. 2 paid the full whack. The 3rd took the cut price option of just having his head frozen. I'm glad they were from Oxford, not from my university. And I told them I'd rather end my days in an English churchyard than an American refrigerator. But if you transcend biology by having your brain downloaded into a machine, another question that arises is, would it still be you? Should you be relaxed about your original body then being destroyed? What would happen if several clones were made of you? These are ancient conundrums for philosophers, but practical ethicists may need to address them in coming centuries. And what about consciousness? Philosophers debate whether this is special to the wet organic brains of humans, apes, and dogs, or whether consciousness and an inner life emerge in any sufficiently complex network that manifests intelligence. This question isn't just semantic. It crucially affects how we react to a far future scenario where electronic machines take over. If the machines are zombies, incapable of appreciating beauty or mystery or wonder, we'd not accord their existence the same value as ours, and the post-human future would seem bleak. But if they are conscious, we should surely welcome the prospect of their future hegemony. The Earth has existed for 4.5 billion years. Most of us, except maybe some in Kentucky, are familiar with this time chart of Darwinian evolution. But many think we are the culmination, And that's not true, because there's 6 more billion years before the sun fuels run out, and before Andromeda crashes into our Milky Way. And the expanding universe will continue, perhaps forever. And to quote Woody Allen, eternity is very long, especially towards the end. So we may not even be at the halfway stage in the emergence of complexity. So even if life had originated only on the Earth, it need not remain a trivial feature of the cosmos. Humans have time to jumpstart a diaspora whereby ever more complex intelligence diffuses through the whole galaxy and beyond. But this prompts the number one question. Is there life out there already? Or is the cosmos awaiting our remote progeny? I wonder what odds Arthur would have given today. Much higher, I guess, than when he wrote his book. Because we now know that there are planets orbiting most of the stars in our galaxy. Billions of young Earths that are potentially habitable, orbiting most of the stars in this sky. Within 20 years, bigger telescopes may provide evidence that some of these planets have biospheres around them. But a biosphere, just vegetation, is not the same as ET. But the question, are we alone, fascinates so many that SETI searches are, in my view, worthwhile, even though the prospects of success may be small. Of course, there are some people who already think they know that there is life out there. I get letters from people who've met the aliens, who've been abducted by them. And I reply by saying, do you really think that if the aliens had made the great effort to come here, would they just have met 1 or 2 well-known cranks, made a corn circle or 2 and gone away again? It seems unlikely to me. And I tell these people to write to each other and not to me. And another thing. Space is far vaster than Clarke ever envisaged. Sorry. Yep. Okay, next one too. We can see billions of galaxies, each harboring billions of planets. A huge vista. But this, the observable universe, is only a fraction of the aftermath of our Big Bang. We'd expect far more galaxies located unobservably far away. Indeed, if they stretch far enough, then all combinatorial options will be repeated. Far beyond the horizon, we could all have avatars. But that's not all. Our Big Bang may not be the only one. It could be just one instance in a vast cosmic archipelago. For instance, we could live in a three-dimensional space that's embedded, along with many others, in a fourth spatial dimension. Indeed, we may be due for a fourth and grandest Copernican revolution. We've had Copernicus's revolution itself, then the realization that our solar system is one of many, then that our Milky Way galaxy is one of many. But maybe our Big Bang is one of many. Multiverses are still speculative physics, because we don't have a battle-tested theory which describes the very beginning of the Big Bang. We need to sort out this decision tree. About 10 years ago, I was on a panel at Stanford where we were asked how much we'd bet on the multiverse concept. We were asked to put it on the scale, would you bet your goldfish, your dog, or your life? I said I was nearly at the dog level. And the Russian cosmologist Andrei Linde, who'd spent 25 years promoting his version of the multiverse, he said he'd almost bet his life. And the great theorist Steven Weinberg then said he'd happily bet Martin Rees's dog and Andrei Linde's life. Well, Andrei Linde, my dog, and I will all be dead before this is settled. But it's not metaphysics. It's highly speculative, but it's exciting science. Now, just a few comments on the scientific endeavour, crucial to understanding the world and, of course, to changing the world. What have we learned? What might we learn? And what may we never know? This Ouroboros depicts the unity of all cosmic processes. Very small on the left, very large on the right. Not only do humans share a common origin with the entire web of life on Earth, but we're made of atoms that were forged from pristine hydrogen in faraway stars long ago. We're stardust, or less romantically, we're the nuclear waste from the fusion that made stars shine. But although there are deep questions in cosmology, it's surely worthwhile to try and tackle them. What questions describe the bedrock of physical reality? What breathes far into those equations? How might our vast complex cosmos have evolved from something microscopically small? A mind-blowing cosmic extension of Charles Darwin's realization that all life evolved from a simple beginning. And are we in a multiverse? Answers may come into focus in the coming decades, but maybe not. There's no reason why the capacity of human brains should be matched to an understanding of the deepest reality, any more than the brain of a chimpanzee is. We may hit the buffers without AI or posthumans to help us. And, by the way, the challenges of physics and cosmology aren't the most daunting ones. Indeed, although it may seem, some of the best understood phenomena are far away in the cosmos. Astronomers can explain confidently two black holes crashing together a billion light years away. In contrast, our grasp of some everyday matters that we all care about, diet and childcare, for instance, is so meagre that expert advice changes from year to year. But this actually isn't paradoxical. The very small on the left and the very large on the right are less challenging than the very complex in the middle. The smallest insect is structured far more intricately than a star or a galaxy. And we, of course, are the most complicated things in the universe we know of, at least so far. But let me end by zooming in from the cosmos to the realities here and now. My key message would be this. Even in the context of the concertina timeline, extending billions of years into the future as well as into the past, this century is special. It's the first when one species, ours, has the planet's future in its hands. Our creative intelligence could jumpstart the transitions from an Earth-based to a spacefaring species, and from biological to artificial intelligence. Transitions that could inaugurate billions of years of post-human evolution, even more marvelous than what's led to us. On the other hand, a more empowered and demanding human population could, during this century, trigger bio, cyber, or environmental catastrophes which foreclose all such potentialities. Spaceship Earth is hurtling through the void. Its passengers are anxious and fractious. The life support system is vulnerable to disruptions and breakdowns. We need imagination to plan globally, to plan rationally, to plan long-term, empowered by 21st century science and technology, but guided by values that they alone can't provide. So our Earth, this pale blue dot in the cosmos, is a special place. It may be a unique place, and we're its stewards at a especially crucial time. And that's an important message for us all, and would surely have struck a resonance with Arthur C. Clarke. Thank you for listening.
questions, please. Can we get your microphone?
Right.
Mike Nelson, I'm a professor at Georgetown in my spare time. I give out lots of reading assignments. If you were to tell a 15-year-old to read 2 books about the universe, what would those 2 books be?
So I didn't catch that, yes.
If you could tell a 15-year-old 2 books to read
About the universe, to inspire them.
Okay, well, I think one of them would be Arthur C. Clarke's, and the other would be my book, which is called On the Future, Prospects for Humanity. Yeah.
In your bio, it talks about several universities that you had visiting professorship. I was curious if you could tell us a little bit about any of those that you would like to in regards to the international locations or the Smithsonian or anything from that perspective.
Well, I think the important point I'd make is that science is the one truly global culture. Science transcends all boundaries of faith and nationality. And so scientists have traditionally been more mobile, and that's why it is important for scientists to travel to foreign centers of learning. And indeed, if you look at the authorship of many papers, especially in my subject, they are multinational. So it's a very international topic, and certainly within Europe, we have to combine together to afford the best equipment. And in fact, we are now building the world's biggest optical telescope, the one that will be the first to discover evidence for a biosphere around other planets. It's got a 39-meter diameter mirror. That's probably a bit bigger than the width of this room. It's called the Extremely Large Telescope. The Europeans aren't very imaginative in their nomenclature. But that's just an example of collaboration. And the ALMA radio telescopes in Chile, they're world collaboration. Europe, North America, and Japan. So it's very important that we should be international.
Way in the back there.
Thank you. Steve Brody with the International Space University. For those of us that have long read space science fiction or futurists like Sir Arthur, not too much is surprising. Right. For example, Profiles of the Future is one of my favorites as well.
Right.
What would you say was very surprising to you in scientific or technological development that really essentially blew your socks off?
Mm-hmm. Well, I think you're right in saying that the fiction writers got things ahead. In fact, when I was a kid, I read a comic called The Eagle, which made me familiar with spacesuits and rockets and all the rest of it long before the first moon landing. So the speculators were way ahead. If we ask what surprised me most, I think probably nothing in space science. I think some things that we've learned about the very distant universe with our telescopes, but also in other subjects. I mean, I think some of the things discovered in brain science have completely blown my mind. How animals find their way around by neurons responding to particular locations, things like that. So I think science is amazing. And for those of the people here who are going into science, the younger people, I think you've got to choose a subject which is advancing fast. New techniques and new discoveries, then you can do things the old guys never had a chance to do. And I think the fortunate thing is that science is advancing rapidly, and as it advances, the frontier gets longer, so there are more new questions just beyond the boundary, which are challenging to the next generation.
Good evening. Hi, Lord Rees. Corey Lathan, we met at dinner. I wanted to ask you a question about your personal views on longevity. You mentioned Ray Kurzweil and some of your colleagues
yes.
who are doing some crazy things.
Yes.
But, you know, I would do some crazy things. As I get older, I fully expect to replace my joints. I expect to have better than 20/20 vision. Yes. I'm ready for that implant that's going to help me retain my memories as I age. Yes. So I would love to hear your thoughts on, you know, the future of technology and human enhancement and longevity.
Yes. Well, I mean, of course, we can hope that we can live a bit longer by the advances in medical science and cyborg techniques, perhaps. But the question is, will there be a big leap due to some breakthrough in showing that aging is a sort of disease we can cure? We don't know. If that happened, then of course that would have huge consequences for family structure, population, and all the rest. And Kurzweil et al., of course, are counting on something like that happening, so that if they could live another century, then they might thereafter become immortal, but he's in his 60s and he needs this sort of intermediate stage, frozen in liquid nitrogen, in order to have this chance. I have to say, I think that what he is doing is really stupid because the chance is so small, and also unethical, because if you think of someone who is frozen, and if the company survived and fulfill its obligation to revive you into a world, then you'd be a burden. We feel an obligation to look after refugees or people from some tribe whose habitat's been destroyed or something like that. We have an obligation. But these people are voluntarily putting a burden on future generations for which they will be aliens. And so I don't admire what they're doing at all. Apart from being a waste of money, in my opinion.
I think we have time for one more.
Let's say that I'm the supreme deity or the smartest thing in the universe, and I can answer any question you have about in your mind about your discipline. You have one question that you are dying to have answered, the holy grail of your research. What is it? What would you really like to know?
Well, perhaps let me give you two answers.
You can only choose one. No,
yes, yeah. Okay. Well, no. The first answer is a very conventional one, because I think is there intelligent life out there? Is, I think, the number one most fascinating question for everyone. But I think to give a slightly more specialized answer, I would like to know: is there some fundamental theory unifying the very large and the very small? As on the Ouroboros, the left-hand side and the right-hand side, which allows us to understand the very beginning, where the snake is eating its tail at the top because the very large and the very small interact, where everything is so compressed that quantum effects shake the entire universe. We want to know, is there a theory that allows us to understand that? And if there is a theory, can we understand it? Because the three possibilities. One is we can understand this theory. Secondly, there may not be any such theory. But thirdly, it could be that there is one, but it's beyond human capacities to understand it and work out its consequences. But here perhaps AI can help. So there may be in the future a class of theories which we know are correct because AI can work through immensely complicated mathematics and spew out an answer which agrees with observations. But that's not giving us understanding or insight. We really want insight, but there may be theories which are correct, and we know they're correct, but we don't really understand them because our brains aren't up to it. But it's very important to bear in mind that there's no particular reason why our brains should be matched to understanding these, because a monkey can't understand quantum theory, and it's amazing that our brains, which haven't changed since our ancestors roamed the African savannah, can understand things so far from common sense as quantum theory and the cosmos. So it's amazing how far we've got. But there may be deeper aspects of reality that we're just not aware of. And we have to be open-minded about that and leave that to the post-humans.